Hi, this is the course General Chemistry 1A, and this is a tutorial for the chapter Properties of Gases. Let's take a look at this question. So there is a noble G gas which belongs to the group 18, and the amount is half mole, and it resides in a closed container with a constant volume of 2 liters. So that is a very important information that the volume is constant. And then the density of the gas in the container is around 5.045 gram per liter, and the gas is assumed to behave as an ideal gas. So in that case, we can use the formula to calculate the relationship between, for example, mole, pressure, volume using the ideal gas formula. So in that case, this one over here, we can use this formula. Now let's take a look at the information. So we have first is the n, which is small. So n equals to half. And then we have a constant volume, which is 2 liter. And then we have a density of the gas in the container, which is 5.045 gram per liter. And then now we have to calculate the pressure in atmosphere of the noble G gas in the container above, that the temperature is at 27 degrees Celsius. So we have now a new information over here, which is 27 degrees Celsius. And then don't forget that we have to use the absolute temperature, which is in Kelvin. So in that case, we are going to add this. So now we have 300 Kelvin. So now we can calculate the pressure in atmosphere. So pressure is based on this one over here, the formula for the ideal gas. So nRT divided by the volume. So we have the information of n, we have R, which is the gas constant, and then we have the temperature, and then we also have the value of the volume. So in that case, we can calculate this equation. So we have half mole. And then because we are going to calculate the pressure in atmosphere, so we are going to use the R constant in liter atmosphere per mole per Kelvin. So this one. Okay. And then the temperature is the absolute temperature. So we are using the 300 Kelvin over here. And then divide it by the volume. Now the volume should be in liter. So we have 2 liter over there. Okay. So you can see from the unit that we use that we are going to have the pressure in the unit of atmosphere, which is what we look for. So we are going to calculate this. So this one here, the pressure is around 6.15 atmosphere. Now the question B, calculate the molar mass of the gas G, and then based on the calculation, identify the gas G. So remember that the molar mass, the unit of the molar mass is gram per mole. So we are going to need the mass, and then we are going to need the informations of mole. Now, to calculate that, we know that we have half mole and we have density, so we can calculate the mass. So, for example, here, mass can be calculated from the multiplication of volume multiplied by the density. And then we have the volume of 2 liter because the volume is constant. And then the density is around 5045 gram per liter. So you see that from the multiplication of the unit, liter and gram per liter, then we will end up with gram as the unit of mass. So here, okay, the result is around 10.09 grams. This is the mass of the gas G. And then we also know that the mole of the gas G is around half mole. So in that case, we can calculate the molar mass. So molar mass is mass divided by the mole. So here we have 10.09 grams, and then divided by the mole, which is half mole. So here we have 20.18 gram per mole. So we are going to look for the periodic table and then look at the group 18 because we have that information here. And then see like which element which has the molar mass of 20.18. Here we can check the helium has 4 gram per mole, and then the neon over here has around 20.1797 or around 20.18. So in that case, we can conclude that the gas in the question is neon. So over here, we can conclude that the gas is neon. So the gas G is neon. Now let's take a look at question C. The container used in this experiment is only able to hold a gas pressure up to 10 atmosphere. Calculate the maximum temperature in degrees Celsius of G gas to avoid the explosion of the gas container. Okay, so the maximum pressure that it can hold is around 10 atmosphere. So let's write it down. And we know that the volume of the container is 2 liter. And then we want to know what is the maximum temperature of this gas when it reach 10 atmosphere of pressure. So we can again use the ideal gas law. So in that case, we are going to look for the value of T. So this is the ideal gas law. So then we have this formula PV and R, and the amount of the gas is half mole. So we can calculate this. The P is 10 atmosphere. That's the maximum that the container can hold. So we have 10 atmosphere. And then the volume is 2 liter. And then the mole is half mole. and then the gas constant is 0.082 liter atmosphere per mole per Kelvin. And then we can calculate that here the temperature is 487.805 Kelvin. Because the question is asking you to calculate the temperature in degrees Celsius. So then we can convert this. So T is in Kelvin minus 273. So here we have the value of temperature in degrees Celsius. Okay, now the next question, calculate the density in gram per liter of the G gas if all the gases were moved into another closed container with a volume of 5 liter at the same temperature. Now we are assuming that this question is constant temperature as in the information of the problem, which is 300 Kelvin, so 27 centigrade. When the volume equals to 2 liter, we have a density value. So let's say this is V1, and we have the information that the density is 5045 gram per liter. And then now we are calculating the second condition in which the volume is 5 liter. And then we are going to calculate this density. Now, because we know that all the gases were moved into another closed container, so we know or we assume that there is no change in the amount of the gas. So the number of the gas stays the same. And we know that the mass of the G gas, based on the question B, that is around 10.09 gram. So here we have here. So the mass is 10.09 gram. Now the mass stays the same. In that case, we can calculate the density here, which is mass divided by the volume. So here we have the mass, which is 10.09 gram, and then divide it by the 5 liter. So this is now 2.018 gram per liter. So this is the new density of the gas when it is moved to a new volume. Now let's take a look at the question E. Other gases which are hydrogen gas 0.1 mole and nitrogen gas 0.15 mole are added into the container at question D. So now we are using the 5 liter volume, and then the three gases do not react one another. So now we have a new container which has the volume of 5 liter. So the volume is 5 liter, and then we have neon, okay, the noble gas, and then we have hydrogen gas, and we also have nitrogen gas. And then the first question is calculate the partial pressure in atmosphere of nitrogen gas at 27 centigrade. The partial pressure is a pressure in which we calculate by assuming that only one gas is present in a container. So we are going to have 5 liter as the volume of the container, and then calculate the pressure of the nitrogen when it is assumed that only nitrogen is present in the container. So in that case, we need the mole of the nitrogen. So mole of nitrogen is 0.15 mole. So again, we can calculate P and RT divided by volume. So here we have like 0.15 mole, and then the gas constant. And then the temperature. So for example, here there's an information that the temperature is 27 centigrade. So we have here T equals 27 degrees Celsius, which is 300 Kelvin. So here we have 300 Kelvin as the temperature. And we are going to divide this by the volume of the container, which is 5 liters. So we have here 0.738 atmosphere. So this is the partial pressure of nitrogen. So this is the value of the partial pressure of nitrogen. And then the next question, calculate the ratio of the partial pressure of the G gas and the hydrogen gas if the temperature were rise to 127 centigrade. So now we have T, which is 127 centigrade. So we have to convert it into Kelvin. So add 273, 400 Kelvin. So when we want to calculate the partial pressure of the G gas, which is neon, so for example, P neon, the partial pressure of neon, is the mole of neon multiplied by RT, and then divided by the volume. And then the partial pressure of the hydrogen, so P of hydrogen over here, and this is the N mole of the hydrogen, RT, divided by the volume. So there's an information that the temperature is rise to a higher temperature, but this is for the same system, for the same container. So if we only ask to calculate the ratio of the partial pressure of neon and the hydrogen, then we only need the ratio of each mole. So in that case, we can calculate pressure of neon, hydrogen equals to the ratio of mole. Okay, now the mole of neon and then the mole of the hydrogen is 0.1 mole. So the ratio is 5 to 1.